Welcome, my dear students. Myself, Sjctnc-Matlab-Unit, Assistant Professor, Department of Mathematics, St. Joseph College of Arts and Science, Autonomous at Cuddalore. This is the video for MATLAB. It is an Unit 3, Part 1 video. Last two units, Unit 1 and Unit 2, we discussed about the basic concept of the MATLAB and different windows in MATLAB and how to work the windows and how to write a program using that window all are already seen. So now we're going to discuss about that programming in MATLAB. So if you want to write a program, we use some tools and we use some structure and we use some operator. So that one we're going to discuss now. So in this video we're going to see some operator. We know some operator or relational operator, logical operator, condition operator and looping statement, switch cases also. Here we're going to see deeply the relational operator. So first thing we're going to see how to work the program in MATLAB. MATLAB provides several tools that can be used to control the flow of a program. Conditional statement and switch structure make it possible to skip command or execute a specific group of command in different situations. For loop and while loop make it possible to repeat a sequence of commands several times. It is obvious that changing the flow of a program requires some kind of decision making process with the program. So now we're going to see the operator, relational operator. The relational operator compares two numbers by determining whether a comparison statement, for example, we are taking two values 5 and 8, that is 5 less than 8. So we know what is the mathematical result. 5 less than 8 means we are comparing two numbers. So that 5 less than 8 is true or false. So if the statement is true, it assigned to the value is 1. If statement is false, assigned to the value is 0. So the relational operator says we are comparing two expression or two numerical value. The expression is true, the value is 1. The expression is false, the value is 0. It does not display by any string. It displays only the numerical constant, either 1 or 0. The logical expression is true, false statement and produces a result which is true means 1, false means 0 according to the specific operator. For example, the logical AND operator gives 1 only if both the statements are true. Both of the statement is true, the expression result is provides the value is 1. If both the statement is false, the value will be produced as 0. So now we're going to see the relational operator. So the relational operator are, the first one is less than, it is we are using less than symbol. Second one is greater than and third one is less than or equal. By mathematically we are writing less than or equal to means like that, but here we should not use like that. We use only less than or equal. So similarly for the greater than or equal to and equal to equal. By mathematics we are equal means we have simply used only 1. Here don't use like that. We use equal to equal. So not equal, we are using the negation with the equal symbol. That is a not equal. So that is the less than or equal symbol, not equal symbol. So now we are using the relational operator. So the relational operator are used arithmetic operator with a mathematical expression. The result can be used in other mathematical operation in addressing array and together with the MATLAB command. Example, if statement. When two numbers are compared, the result is 1, logical is true. If the comparison according to the relation operator is true, and 0, the logical is false, the comparison is false. If two scalars are compared, the result of scalar is 1 or 0. If two array are compared, the comparison is done by element by element. So we already seen the second unit element by element operation. So the array are verified here only by the element operation. So now we're going to check the scalar formation. So if the scalar is compared with the array, the scalar is compared with every element of the array, the result is logically array with ones or zeros according to the outcome of the comparison of. So now we're going to see some example. 5 is greater than 8, the value is false, the value is 0. 5 is less than 10, so the value is 2, therefore we produce 1. So next we're going to see some expression. Y equal to 6 less than 10 plus 7 greater than 8 plus 5 star 3 equal to 60 divided by 4. So that is, here they are having three different expression in bracket. So we call bracket. So we know the precedence of the arithmetic operator by the bracket. The inner parenthesis is first evaluated. So like that we have evaluated 6 less than 6 less than 10. It is for true, so the value is 1. 7 greater than 8, it is false, the value is 0. So 5 multiplied by 3 is 15. It is equal to 16 divided by 4 is also 15. So 15 equal to 15. So therefore the value is 1. So therefore now we add 1 plus 0 plus 1. So therefore the result is to be provided as 2. So similarly we're going to check the same value in the mathematical tool. So what is that expression we are seeing? 6 less than 10, 7 greater than 8, y equal to 6 Sjctnc less than 10 plus 7 Sjctnc greater than 8 plus 5 star 3 equal to 60 divided by 4. So we enter, so we will get the value is 2. So we having the value is 2 here. Okay. So similarly we will going to see the array structure. So if B is equal to, we are taking the matrix 15, 6, 9, 4, 11, 7, 14, and C will be the another matrix. So now we will check that C is greater than or equal to that B. So then we compare 8, first one, 8 is greater than 15. So it is false, so therefore the value is 0. Next 20 is greater than 6, true 1. So like that the remaining term. Similarly we can verify B equal to C and B not equal to C and B minus C is greater than 0. So now we are going to check the same thing in MATLAB. For example, we choose any matrix A equal to 3, 5, 8, 9. No need to display, so we enter semicolon, and also we take another one B equal to, for the same we are using 1 row 4 column, using 7, 9, 0, 3. No need to display B. So now we are going to verify that C equal to B strictly greater than A. So enter, what are the terms only greater than A? The term places as 1, remaining will be 0. So next B not equal to A. Display which are not equal. All the terms are distinct, all the places of elements are distinct. So element by element means each place only they have to verify. Because all they are not equal, so 1 1. So equal as all they are false, therefore value will be 0. Suppose if B is strictly greater than 2, only you want to display. Second place, third place, fourth place, only 2, remaining place 0. So this is the way we're going to verify it. So now we're going to check similarly a matrix also. So suppose if you are taking a matrix, A matrix, 3 by 3 matrix, if you want to display a value less than or equal to 2, only you want to check means. So B matrix will be A equal to less than 2. So here the place is equal to 2, the value is 1, 9 equal to 2. Here 4, 9 is value should be greater than 2. So therefore 0. 4 is greater than 2, it is 0. 3 minus 3 is greater than less than or equal to 2. So value is 1. 5 is greater than 2, 0. 2 equal to, so value is 1. 6 is greater than, so far 0. 7 is 0. So last one is 1. So like that they have to, the value of the matrix is displayed 1 0 0 1 0 1 0 0 1. Suppose the next thing, the result of the relation operation with vectors, which are the vector with 0 and 1 are called logical vector, can be used addressing of the vector also. So we know how to represent the value. True means 1, false means 0. So like that the addressing also we can provide. Address means A equal to 8, 12, 9, 4, 23, 19, 10. If you want to display the A value, R value, and we define another variable S equal to R should less than or equal to 10. So therefore S is only displayed. Now we are going to check another one T equal to R of S. So that is 10 whose the elements, whose the positions as less than 10, they will be displayed value is again the same number. It is 8, 9, 4 and 10. So these are the elements. The vector T consists of element R in position where S is ones. Similarly, we can find a value, find the R equal to R of less than or equal to 10. They are equal. So the numerical vector and array with the numbers zeros and ones are not in the same as logical vector and array with zeros and ones. The numerical vector and arrays cannot be used for addressing, and logical vector and arrays, however, can be used in arithmetic operation. The first time a logical vector or an array is used in arithmetic operation, it is changed to a numerical vector or array. Order of precedence in the mathematical expression that includes the relational and arithmetic operation. Arithmetic operation will know addition, subtraction, multiplication, and division, right division, left division. So having the precedence over the relational operator, the relational operator themselves have an equal precedence and evaluated from left to right. The parenthesis can be used to alter the order of precedence. So now we're going to see the example here. So 3 plus 4 less than 16 by 2. So by the precedence of operator, the division it will be the first. So 16 divided by 2, the value is 8. So next we will verify the addition. So 3 plus 4 is 7. So now we will check 7 less than 8, the value is 1. So it is true, therefore we display 1. So now similarly we can here within the bracket parenthesis the value must. So therefore 4 less than 16, it is the true cases. So therefore value is 1. So 1 divided by 2 means, so 1 divided by 2 as value is 0.5. So the value having 3. So 3 plus 0.5. So value is 3.5. So like that way their expression is done in all the places. Now we're going to check the same thing. So what does that mean? Some expression. So 3 plus 4 less than 16 divided by 2. So answer is 1. So next 3 plus 4 less than 16 divided by 2. 4 less than 16. 16 divided by 2. Answer is 3.50. So like that we can evaluate any expressions using the relation. So next video we will going to see the logical operator and our conditional operator and so on. Thanks.